In the last video I showed you how you can build a simple CTC panel with Neopixel LEDs and then use them to display turnout positions or block occupancy and trigger routes using the Arduino inputs together with the event handler function of the IoTT Stick. Today I am going to demonstrate how you can do the same but different using a feature built into the DCC EX software you may not be familiar with, X-Rail scripts. Welcome to the IoTT channel, I'm Hans Tanner. A special welcome to all new subscribers and welcome back to everyone else. I'm happy to see you back here. X-Rail is a scripting language that is built into the DCC EX command station and that allows you to automate certain control tasks like setting routes, reacting to sensor changes, or even implementing simple train automations like a trolley line with trains going back and forth. From a technical point of view, it is rather astonishing that such functionality can be provided on a small microcontroller like the 328P found on the Arduino board. And I think it is quite a masterpiece of programming to make it work. Keep that in mind if you ever hear me say critical things about X-Rail. Making X-Rail work despite the platform limitations of course comes with some compromises that might be unexpected, so in this video I will start out with a quick introduction of some key characteristics of that scripting language, basically the stuff I think would have been useful to know before getting the feet wet. Then I will use the example of the CTC panel from the last video to show how to use an X-Rail script for a simple automation of button input, route setting and block occupancy indicators. If you are familiar with script languages in other applications, here is the first big difference. In typical script languages, like for example JMRI scripts, you can type your script into an editor window while the main application, so JMRI, is running. When done, the application loads and executes the script. In X-Rail, on the other hand, scripts are entered into the DCC EX source code, because technically speaking, X-Rail commands are macros that are replaced by the compiler with code fragments before compiling and redeploying to the Arduino board. And therefore, if you want to play with X-Rail, there is no way but to install the Arduino IDE on your computer and download the DCC EX source code so that you can recompile DCC EX every time you make a change to your X-Rail script. Maybe this sounds cumbersome to you, but it is actually not. You can conveniently install the Arduino IDE from the Windows Store and download the DCC EX source code from the DCC EX webpage. Just follow the instructions on the DCC EX webpage linked in the description and you will see it only takes a few minutes. X-Rail still is under pretty active development and new functionality becomes available quite frequently, so if you really want to dive into, you may want to install the latest developer version. However, to make the examples in this video work, it is best to use the current production version 4.15 along with the newest version of the IoTT Stick software, currently version 1.6.0. To get started with your own script, you should create a new file in the Arduino IDE and name it myautomation.h. The name is case sensitive, so make sure you name it exactly like this. This is the file where you can enter your first scripts. Later on you can create and use additional files so you can organize your script code, but for now that's it. If you create this file, it will be used instead of the file named myautomation.example.h, which is part of the source code. You should not use the example file as it is replaced every time the source code is updated and you will lose your scripts. The myautomation.h on the other hand is your file and will not be overwritten by updates. Once this is working, you are ready to enter scripts using the commands specified in the X-Rail documentation. Here are a few characteristics you should be aware of though. First, there are two different types of functions you should distinguish: sequences and event handlers. The difference is in how they are triggered. Event handlers are triggered every time a defined event occurs. Right now, there are only two event handlers available, called onClose and onThrow, and they fire if the turnout with the specified ID is changing to the respective position. If that happens, the commands following the event keyword are executed until the keyword done is found. This execution is completely autonomous, just based on the event happening. Unfortunately, at this time there is no event handler that would fire when an input state change occurs, but chances are this is something that will be available in future versions of X-Rail. The second type of code segments are started with the keywords sequence, route, or automation. From a functionality point of view, routes and sequences are identical, while automations are different as they can be started with a locomotive address as parameter. The important difference between the three types is the visibility from the outside. If a sequence is labeled as automation or route, it will be listed in the engine driver smartphone app and it can be executed from the app. This is not the case for sequences labeled as sequence. The idea of the concept is that sequences are used for internal stuff, routes are used to activate a list of turnouts and signals, and automations are used to implement scripted train movements. All three types of sequences use the same structure, starting with the keyword, then a list of commands to be executed, which is then ended with the keyword done. Also important to know that several sequences can be executed simultaneously, and they can be started at any time, either from the outside or triggered by another sequence. And even one single sequence can run several instances. So one single script to run a train can be started with two different locomotive addresses, and two trains can run independently. Of course, if you do that, you have to make sure the script handles all necessary block detection and routing to avoid train collisions. As an additional feature, sequences can be defined with the AutoStart keyword, which causes X-Rail to start the execution right after starting up the Arduino. One important limitation to be aware of is that there are no variables that can be defined and used to temporarily store calculation results. Well, almost. There are two sets of 255 1-bit flags named blocks and sensors. These flags can be set and released with the commands reserve and free for blocks and latch and unlatch for sensors. I think that is the important conceptual upfront information, so let's get started with the example application. In the last video I showed this slide to discuss system integration and decided to implement the button and route functionality using the event handler provided by the IoTT Stick. What I'm doing now is moving that functionality over to X-Rail, so closer to where the button input is happening. As a result, I do no longer have to send the button inputs over to the stick. But of course, I still want to have the information about turnout positions indicated on the LED matrix. So what I have to do is setting up the route in X-Rail and implementing a function that watches the input buttons and triggers the route and turnouts when a button is activated. But before I do that, I run a sequence that does most of the initialization, and that is a feature I really like about X-Rail. In the last video I showed you how you can define sensor inputs and turnouts using the dialog function of the IoTT stick, either storing it locally on the stick or in the EEPROM of the Arduino board. And I briefly mentioned a third way, which I think is more convenient in most situations. Here it is. Xrail allows for putting the definitions in a sequence and execute it automatically when the system starts up. Doing it this way gives me a configuration that is easy to change, but is permanent as it gets loaded automatically every time the Arduino starts up. So I define a sequence right at the beginning of the Xrail script. I use the keyword AutoStart and add the commands for defining the turnouts. First, the DCC turnout with address 2, then the pin turnout on pin 22. Conveniently, Xrail has commands for defining turnouts. Unfortunately, there are no commands for defining sensors, even though there probably will be one in future versions. But I can use the parse function and the API command to define them. So sensors 23, 25, 27 and 29, just like last time, but directly integrated in the Xrail code. Finally, I add turnout 5, which I will use to trigger the route from remote. I now compile the code and upload it to the Arduino. Note that the IoTT stick may have to be disconnected or at least switched off when uploading the Arduino sketch, so that it does not block the serial port. This is not consistent though. I have some Arduinos that work with the stick active and others don't, so you will have to test with your own setting. I now turn on the IoTT stick and load the Red Hat page, and when I click on the Inputs tab, I see the list of defined inputs that was automatically loaded from DCC EX. The only thing I need to add is the LocoNet message type and address I want to use, so I select Input Report and enter the LocoNet addresses 101, 2, 3 and 4. Clicking the Turnout tab, I see the list of defined turnouts along with the type. As said in the Xrail script, the turnouts with IDs 2 and 11 are DCC turnouts, while the turnout with ID 12 is a V-pin turnout operating pin 22 of the Arduino. The LocoNet address for the DCC turnouts is already defined in the Xrail script, so all I need to do here is setting the LocoNet address for the V-pin turnout, which I set to 2. And as we already saw in the last video, there is an offset of 1 between the LocoNet addresses on the stick and the DCC address in DCC EX. So the DCC address 2 specified in the Xrail script is shown as LocoNet address 1 for the turnout with ID 11. After setting the LocoNet addresses, I click Save and Restart to save the settings on the stick. When the Red Hat web page reloads, you briefly see the OK field turn to Not Set and then go back to OK, indicating that the settings shown on the screen are identical with the ones found on the Arduino. If I open the LocoNet viewer and connect the input pins to ground, I see the input report messages flowing, and with the settings of the LED chain unchanged from the last video, the occupancy LEDs on the LED panel change from yellow to red and vice versa. And if I connect engine driver to operate the turnouts, I can verify that the turnouts are working. DCC commands for turnouts 1 and 5 are sent to the track, and turnout 2 operates the LED on pin 22 of the Arduino. So far so good, everything works and the entire setup was done with just a few lines of Xrail script code. I think you see why this is my favorite way of setting up turnouts and inputs. Next, I define the route. As in the last video, all I wanted to do is setting the turnouts with DCC addresses 1 and 2 to closed. And of course I need to make sure that the stick knows about the position change so that the LED can be updated. So I start a new route sequence and give it an ID number and description. The ID number must be unique for sequences, routes and automation. You cannot have a route with ID 25 and an automation with ID 25. For larger applications, it therefore would be a good idea to define certain ranges of ID numbers, so they are easy to recognize. In this example, I use IDs 101 to 150 for sequences, 51 to 100 for routes, and lower than 50 for automations. The next entry is the close command for turnout 1. Note that I need to use the turnout ID, not the DCC address, as only DCC turnouts do have a DCC address within X-Rail. The V-pin turnout does not, but it has an ID number. Next, I put in a short delay to separate the two turnout commands. Note that you can use the delay command without risk, as it is non-blocking. It just stops the execution of this particular sequence, but has no impact on all other sequences or the Arduino program itself. I point that out because if you ever took some lessons about programming in Arduino, most likely you were taught that using the delay function is a real bad idea because it stops the execution of the entire sketch. And generally this is the case, but in the X-Rail script it is safe to use delay. In the remainder of the sequence, I repeat the close command for the second turnout and end the sequence with the done statement. The route can now be triggered using the start command from the command line. When executed, each close command sends a notification so that the stick can know that the turnout position changed. H is the opcode, 11 and 12 are the turnout IDs, and 0 stands for closed. Looks like the route is working as intended. As you remember from the last video, I also had the requirement to trigger the route by setting turnout 5 to thrown. I want to be able to do that so that I can trigger the route from a typical handheld throttle that only can issue turnout commands but not route commands. Doing that is now really easy using the turnout event with an event handler that simply calls the route. In the initialization sequence, I have already defined the turnout with DCC address 5 and ID 2. So all I need to do is define an onThrow handler for turnout ID 2. When the event is called, I use the follow command to branch to the route sequence. The follow command makes the execution jump to the specified location, in this case the route with ID 51. Finally, I end the event handler with a done statement. In this particular case, the done would not be needed as the program never comes to that point, but it is good practice to put in a done anyway, as it helps later on to analyze the code in case I need to do some debugging. If I want the outside world to know that the status of the switch has changed as a result of setting the route using a local button input, I can add another broadcast command to the route, sending out an H command for switch ID 2, which is DCC address 5. Again, I compile and download the code to the Arduino, and when I issue a turnout thrown command, I see the additional turnout commands from the route coming through. First in the Arduino monitor from the Arduino itself, but then I see them as well in the LocoNet monitor of the IoTT Stick. Finally, the button functions. Remember from the previous video, I want to use 4 buttons on IO pins 47, 49, 51 and 53. The first button toggling switch 1, the second and the third setting switch 2 to closed or thrown, and button 4 triggering the route. As I mentioned before, there is currently no event handler for regular input pins, so a simple solution like on change 47 does not exist, and I have to find another way. There is another command that appears to be useful, add. In the documentation it is described as event handler, but that's not really the case. It is a function to await a certain condition. The function can be called inside of a sequence for an I/O pin, and it stops the execution of the sequence until the condition is met. A pin can only have two states, so we can implement a sequence that first waits for the pin to go high, then does something, then waits for the pin to go low, and then keeps looping. So first I create a sequence that switches the turnout with ID 12 to thrown every time the button 49 is pressed, meaning the input is pulled to ground. I make it an auto start sequence so that it gets loaded when the Arduino starts up. Then I use the add function to wait for pin 49 becoming active, and if this is the case I set turnout 12 to throw. Then I do a safety delay in case there is some bouncing on the contact, and then I start waiting for the button to be released. Another delay and then a follow to restart the function from the beginning. Obviously, this function never reaches the done statement, so it just keeps going round and round, switching the turnout every time the button is pressed. Now I do the very same for button 51 and setting the turnout to close. And for button 47, which should toggle turnout 11, the function looks very similar. The only difference is that when the button is pressed, I first check the current position of the turnout and then issue a command putting it into the other position. Finally, I do a sequence for button 53 to trigger the route. It is similar, but instead of setting a turnout, I call the route using the start command. The start command starts the route as a new sequence and then goes on with the current sequence. This is different from the follow function, which would branch into the route sequence and the sequence that handles the button input would be ended. So I use start to call the route and go on with observing the button status. Now I compile and download the code into the Arduino, and here we go. All four buttons are working and the turnout position updates are sent to Loconet so they can be picked up by the CTC panel in the first place, but also by JMRI or a white throttle server or whatever other device. And as you see in this example, the input messages from the buttons are not forwarded to Loconet as they are handled internally. However, if I ever wanted to do that, all I needed to do is define the inputs in the initialization sequence, and I would get a message every time the input level changes, just as I do for the block occupancy inputs. Yes, it's that easy and you have the choice. You can implement a CTC panel without even touching the DCC EX code, simply by setting everything up on the IoTT Stick configuration pages as shown in the last video. Or you can dig a little deeper and put some functionality directly into the DCC EX code and have it executed there without the other systems even knowing about. As it is always the case in life, both ways have their individual advantages and disadvantages, and it is for you to prioritize them. My personal choice is to use DCC EX code for configuration elements that remain stable over time and are directly related to hardware attached to the Arduino, and I really like the possibility to define all the inputs, buttons and turnouts directly in the X-Rail system. On the other hand, I am less convinced about the syntax and command structure of X-Rail, so I tend to use the IoTT Stick functionality for that part, as I consider it to be more convenient. And that's it for this video. I hope this information was useful, or at least interesting for you, and you gained some insights into what X-Rail might be able to do for you and how it can be done. If so, please click the like button below to let me know. And if you are interested in this kind of content, do not forget to subscribe to the IoTT channel As I plan to do more videos featuring X-Rail functionality and applications once the now announced upcoming DCC X version is available. Thanks for watching and see you in the next video.